Case study analysis of paint and coating failures. Surface contamination and poor paint adhesion. Lecture by Dr. G. Subramanian, Chief Scientist Retired, CSIR Central Electrochemical Research Institute. A painted galvanized square tube section of bridge railing and other similar parts had been rejected by a transportation department because of a loss of paint adhesion. The client reportedly purchased the hot dip galvanized square tube railing, blasted the surface with steel shot to provide the specified 1 to 2 mil surface profile, and then washed the surfaces with a trisodium phosphate, shortly called TSP solution, prior to painting. A grey colored 2-component epoxy primer was used, followed by a black colored aliphatic acrylic-polyester polyurethane top coat. The time intervals between steps was reported to be approximately no less than 24 hours. It was reported that after the application of the primer, no problems were noticed by the on-site inspector. After the application of the top coat, some blistering was observed. Observed blisters were repaired by locally removing the paint down to the galvanized surface, spot repriming and top coating. No further loss of adhesion had been observed at the repair locations. Other blisters occurred after being shipped and stored at the job site. It was also reported that post beams painted at the same time have not experienced any evidence of poor adhesion. At a later date, a second rail section was submitted that had been repair coated in his shop, as well as large paint chip that had been sent from the job site. The rail section exhibited few areas of paint loss due to poor adhesion. The loss of adhesion occurred at the galvanizing primer interface. The areas were usually observed near the ends of rail section, with the exception of one area near the center of the rail section, where the loss of adhesion occurred at the location of an intentional X-cross cut. Figure 1 shows the photograph showing the as-received painted galvanized rail section. You can see the red pointer showing the intentional X-cross cut. Figure 2 shows a repaired blister area. A few repaired blister areas were also observed in this picture. No blisters were observed in the as-received sample. At locations where the paint was absent, the underlying galvanized surface exhibited a pock-marked texture caused by short blasting. These indentations resulted in a corresponding raised pattern on the underside of the primer. An X-cut was made through the paint in an area where no previous failure of the paint had occurred. Separation occurred readily at the galvanizing primer interface. Figure 3, 10 times magnified, showing particulate material on the primer underside. On the underside of the paint film, considerable particulate material was observed, as shown in figure 3. The particulate material observed on the underside of the primer at the plane of delamination was analyzed for its elemental composition using a scanning electron microscope equipped with an energy dispersive X-ray spectrometer. A spectrum of the particulate material is shown in figure 4. Figure 4 depicts the EDS spectrum of particulate material on the primer underside. The particulate material was found to consist primarily of iron and zinc, which is indicative of short blasting material debris from the short blasted galvanized surface. You can see the peaks of zinc, carbon, oxygen, aluminum, silicon, iron, chromium, titanium, etc. etc. Figure 5 shows the EDS spectrum of the clear picture at the plane of delamination. Chromium was also found in association with particulate material. A spectrum of the underlying surface of the primer at the plane of delamination without any significant surface contamination. You can see the peaks of magnesium, aluminum, silicon, sulfur, chromium, titanium, so forth and so on. Figure 6 depicts the EDS spectrum of the clear galvanized coating at the plane of delamination. A spectrum of the surface of the galvanized coating at the plane of delamination in an area without any significant surface examination has been shown in figure 6. You can see the peaks of carbon, oxygen, zinc, etc. etc. No chromium indicative of a chromate conversion coating was detected on either matting surface. Also, the surface of the galvanized coating at the plane of the delamination was also further examined by Auger electron spectroscopy, which is a surface sensitive method of environmental analysis. Again, no chromium was detected. A spectrum of the primer plane of delamination could not be obtained. Transverse cross sections through the painted galvanized rail were prepared for subsequent metallographic examination. The samples were examined in both the as polished condition and again after etching with a 1% nitol solution, which revealed the microstructure of galvanized coating. The structure of the galvanized zinc coating consists of an outer layer of metallic zinc above an iron zinc alloy layer at the steel galvanizing interface. Figure 7. Photograph is about 200 magnification, showing a depression in the galvanized coating due to short blasting as polished. The depressions are poke marks in the galvanizing caused by steel short blasting are shown in figure 7. The coating thickness was measured optically using a calibrated filler eyepiece micrometer. The average thickness of the primer was measured to be 0.0041 inches, that is 4.1 mils. The average thickness of the top coat was measured to be 0.0031 inches, that is 3.1 mils. These values do conform to the specified minimum intermediate, that is primer and finish coat dry film thickness DFT values of 3 mils per as per paragraph 70806.1.1 of New Hampshire Department of Transportation GAV Paint Specification Amendment to Section 708 Paints. The paint was found to have very poor adhesion at all locations examined with the plane of delamination occurring at the primer galvanized coating interface. Considerable debris from short blasting operation was observed at the plane of delamination, which exhibited a greater tendency to adhere to the underside of the primer. No chromium indicative of a chromate conversion coating was detected on the clean matting primer and galvanized surfaces. The only chromium detected was found to be associated with the iron blasting shot, suggesting that the iron shot contains chromium as an alloying element. Inference: the cause of the adhesion failure appears to be the result of corrosion of the blasting shot and to a lesser extent the surface of galvanized coating. Thank you very much for watching and listening this video.